A piece of board is 3/16 inch thick. What is this fraction written as a decimal? In order to complete this problem, you need to convert your fraction into a decimal, and you do that through division. So you take your numerator and you divide your denominator. 16 does not go into 3, but it will go into 30. And 16 goes into 30 one time. Subtract 16 which leaves you with 14. 16 will go into 140 8 times, and you'll be subtracting 128. When you subtract 140 by 128, you are left with 12. 120 can be divided by 16 7 times. And you are subtracting 112. $120 minus 112 leaves you with 8. And 16 will go into 80 5 times evenly. This is a terminating decimal, and your answer is 0.1875. Coach Kaler ordered t-shirts for the basketball team from 2 different t-shirt suppliers. One supplier charged $14 for each shirt as well as 5% shipping. The other supplier charged $16 for each shirt plus 8% shipping. Part A asks us to write some expressions representing the situation of Coach Kaler ordered the same number of shirts from each supplier. I want to write 2 expressions that represent the shipping charges that she paid to both suppliers. So the only thing we're looking to figure out is how much she paid in shipping. And we want to use X to represent the number of shirts ordered. You can see that I've already kind of taken the information and rewritten it in a phrase that makes sense to me. 5% of $14 per shirt and 8% of $16 per shirt. And just taking that information and changing it into numbers and letters. The amount of shirts are going to be represented by X. So the shirt here is going to be X. So if it's $14 per shirt, that's $14 times the amount of shirts. And in order to get the shipping for that, we're going to take 5% of that total and pay that in shipping. So when we say of, we're going to multiply, and 5% is the decimal 0.05. So 0.05 times 14x is an expression that represents the first supplier. You can do the same thing with the second supplier. The shirt is going to be represented by the letter X, and we are paying $16 per shirt, so 16x. And again, 8% of that, of represents multiplication, is going to be the decimal 0.08. So 0.08 times 16x. These are 2 different expressions representing the 2 different suppliers. In Part B, the first supplier gave Coach Kaler a discount of 10% off her total order. The second supplier gave her a discount of $15 off of her total order. We want to write 2 equations to represent the total cost that she paid to each supplier. You can use X to represent the number of shirts ordered. So I've taken what I used in Part A and kind of translated it to represent the situation in B, where if you notice, the expression used in A is now here in the total for B. And again, all I've done is changed my 0 to a 1 to now represent that we are paying 105% to include the cost of the shirts as well as the shipping. The same thing for the second supplier as well. I have now made that a 1.08 instead of a 0.08 to represent 100% of the cost of the shirts and 8% for shipping. So if I'm looking for the overall total cost in Part A, then I have to include that I'm taking 90% of that total in order to give myself a 10% discount. So to write that as an equation, the cost will be 90% of your 1.05 times 14x. So everything kind of builds on one another. And for the second order, the cost will represent the total, which is 1.08 times 16x. And now we get to take that amount and take off $15. So these are two equations that can be used in order to get our total cost for shirts ordered. When we are answering the final part here about Coach Kayla ordering 20 t-shirts from each supplier, all you're doing is taking your equations from part B and now replacing x with 20 and solving. So for supplier 1, we will start at our innermost set of parentheses, so we'll say 14 times 20, and 14 times 20 is 280. We will then multiply that by 105%, which is $294. But because we get a 10% discount, we are only going to pay 90% of that cost. So we will multiply by 90%, telling us that Coach Kayla will spend $264.60 if she gets 20 shirts from supplier 1. If we get 20 shirts from supplier 2, we're taking 20 and replacing it with x. So we start at 16 times 20, and 16 times 20 is 320. Following order of operations to reduce this side, we would then multiply by 108%, and that gives us $345.60. And we get to take $15 off of that because that's the discount we're receiving. So that is $330.60. Helen earned $80 from her job yesterday. Today she will earn 20% less than yesterday. And tomorrow she expects to earn 20% more than today. This is all important information in order to us to figure out the combined amount that Helen's going to earn for the 3 days. So overall, we need to take yesterday, add it to today, and add it to tomorrow to get her combined amount. So the problem states that yesterday she earned $80. We don't have to do any work to figure that out. But today, she's earning 20% less than yesterday, which means overall she's going to make 80% of what she made yesterday. Again, if she's making 20% less, then she is going to make 80%. 8 times 0 is 0, and 8 times 8 is 64. Because we have one number behind the decimal, we can see that this is $64 that she is going to earn today. When we look at tomorrow, it's important to read the wording that she is going to earn 20% more than today. And the today's value was $64. If she's going to earn 20% more than that, then she's going to earn 100% of the $64 and 20% more. So that is 1.2, which is 120%. 2 times 4 is 8. 2 times 6 is 12. Don't forget your placeholder. 1 times 4 is 4, and 1 times 6 is 6. When you add these numbers together, you get that tomorrow she will earn $76.80. So to get the combined amount, you will take yesterday, which was $80, today, which was $64, and tomorrow, which was $76.80, and add them all together. So this leaves us with 80 cents and 9, 15, 22. So that leaves us with $220.80 and 80 cents overall of earnings in 3 days. In this graph, we're looking at a representation of London's calories relative to the minutes that he runs on a treadmill. In part A, we're asked to find the change in the calories per minute for 12 and 16 minutes. So if we're comparing the calories per the minutes, and we're looking for overall the calories per minute, we're talking about how many calories did we burn per 1 minute. So the change in calories is that we went from 9 to 15, which was an increase of 6 calories. And when we're looking at the minutes, it took us 4 minutes to do this. So 6 calories in 4 minutes relates to how many calories for 1 minute. All you're doing here is dividing by 4. 6 divided by 4, which is 1.5. So 1.5 calories per minute between the 12 and 16 minute points. We're now looking at the calories per minute between the 20 and 24 minutes. Again, it's calories per minute. And we now have gone from 15 down to 3 calories, so that's a loss of 12 calories. And we have gone from 20 minutes to 24 minutes, so that's a gain of 4 minutes. And again, if we are looking at how many calories for 1 minute, then we're just saying negative 12 divided by 4, which is negative 3. So we have lost 3 calories per minute. For part C, it says during which time period is the change in calories per minute the fastest, and how do you know? Well, if you are losing 3 calories in 1 minute, that is faster than gaining 1.5 calories in 1 minute. So the time period that is the fastest is between 20 and 24 minutes. This problem is a review from Unit 1 where you're having to account for the positive and negative signs indicating which operation to use. So if a company stock begins the week with a price of $34.15 per share, that number is positive. If the price changes by $3.40 each day for 2 days, then again that number is positive, but you have to account for the 2 days. Then the price changes by negative $1.50 each day for 2 days, again for 2 days. On the last day, the price changes by negative $3.75. We're looking for the overall price per share for that company's stock after those 5 days. So if you take that information and you set it up as a problem, you're then just going through the order of operations, in which we are starting with $34.15. And if we are increasing $3.40 for 2 days, then that means after 2 days that we have increased $6.80. We then are going to drop $1.50 each day for 2 days. So that's a $3 decrease. So you're subtracting $3 there. And then we have a drop one time of $3.75. Again, this may be lined up, but because we do have addition and subtraction, you have to take it step by step. So first, $34.15 plus $6.80 is going to leave us with $40.95. We then will decrease that by $3, leaving us with $37.95. We then will decrease that by $3.75, which will leave us with $34.20. That answer choice is C. Braden has a coupon for 20% off of his computer, and the sales tax is 6%. If Braden purchases this computer that is regularly $385, how much is he going to pay, including the sales tax, if he uses that coupon? We'll start with the original price of $385. with the fact that we're getting 20% off, we're going to pay 80%. So we're going to multiply that by 0.8 to represent 80%. And 385 times 80% is $308. So that is the price of that computer that is going to be taxed. And when you pay tax, you have to pay 100% of the price, and then a tax percent more, which in this case is 6%. So we will multiply this by 106%, which is the decimal 1.06. When you take 308 and multiply it by 1.06, you come up with $326.48 that Braden is going to pay for this computer. We want to know how much money Braden's going to save if we're including sales tax by using his 20% off coupon. So you have to figure out what the price of the computer would have been if he did not get that 20% off, including sales tax. So $385. Again, with sales tax, you're going to pay 100% of that price and then a percentage more, which in this case is 6%. So 1.06. So 385 times 1.06 means that the price of that computer would normally be $408.10 with tax. If we want to figure out how much he saved, then you're going to subtract the amount that he paid, which is $326.48. So $408.10 minus $326.48 means that he saved $81.62 on the price of that computer. A lawn crew is raising the price he charges to mow the lawn by 20%. He used to charge $25 to mow a lawn, so we want to know what's the new rate. If we used to charge $25 and now we're going to charge 20% more, we're going to charge 100% of that $25 and 20% more. So that means that we are now going to be paying $30 to have someone mow our yard. So $30 is the new rate. Part B is stemming from Part A. It says, suppose the lawn crew now lowers his rate. So we're talking about the $30, and now we're going to lower that rate by 20%. If we're lowering our rate by 20%, then we're only going to pay 80% of the original. So that translates to $24, because 8 times 0 is 0, and 8 times 3 is 24. We have one number behind the decimal, so $24 is going to be our new rate if we took our increased price and dropped it 20%. In this situation with the pounds of potatoes and pints of French fries, we're trying to figure out the constant of proportionality and the different representations for it. We're talking about looking at equations, we're talking about looking at tables. And remember, we talked about setting up a constant ratio of y over x. So if you took the statement 20 pounds of potatoes for every 4 pints of French fries, that seems like y is the pounds of potatoes and x is the pints of French fries, which gives you a constant of proportionality of 5 over 1, because 20 over 4 reduces to 5 over 1. You can check that same thing with your tables, and we see that the first table is reduced to the same ratio of 5 over 1. And the second table does not, because its ratio reduces to 1/2. But then we look at the first scenario with the equation. And the equation that we look at is typically involving y equals kx. But we said if you can substitute in your variables, then you can make sense of what it looks like. And according to what we've already done, if f is the pints of fries, then according to that being on the denominator, that's like our x value. and P being the pounds of potatoes, and again, according to what we've already done, that's like Y being our numerator, it looks like it should fit the equation Y equals KX as P equals 5F. But we see F equals 0.2 P. So our equation needs to be solved for F instead. So if we're looking at what we've already done, you can manipulate that or rearrange it. Every letter has a coefficient of 1. So in order to solve for F, we divide by 5. And now we are looking at F is equal to 1/5 P. And 1/5 is the same decimal as 2/10. So F is equal to 0.2 P is also a way to represent the same constant of proportionality. Again, you have to be able to establish your variables and make it represent something that we've already talked about, like Y over X, and then move things around from there. This question, which describes a proportional graph, is basically just asking you for the definition of a proportional graph. And we know that proportional graphs are a straight line through the origin. Magic Cars manufactures models of cars for collectors. In July, it manufactured 200 model cars, and in August, Magic Cars manufactured 5% fewer model cars than in July. So in Part A, we're wanting to know what is the difference in the number of manufactured cars in July and August. If in July we manufactured 200 cars, and in August we manufactured 5% fewer, then 5% of 200 means that you're multiplying 200 by 0.05. So that's 0, 0, and 10 with two numbers behind the decimal, meaning that we have 10 fewer cars produced in August, which means that in August, 10 fewer is going to be 190 cars. That'll be important for Part B. In Part B, we're saying of the model cars manufactured in August, 1/4 were NASCAR and 1/3 were vintage. So we want to know how many cars manufactured in August were neither NASCAR nor vintage. Well, if we're talking about in August, we're talking about 190 cars. So the NASCAR models represent 1/4 of 190. So that's 1/4 times 190, leaving us with 190 divided by 4, and 190 divided by 4 is 47.5. We would call that about 48 cars. The vintage cars represent 1/3 of 190. And 190 divided by 3 is 1/3 times 190. 190 divided by 3 leaves us with 63.3 repeating cars, or we could call that 63 cars. So if we took 48 and 63 and added them together, that would tell us how many were vintage or NASCAR, which in this case is 111. We were asking which are not, so we would take our total of 190 and subtract the amount that were either vintage or NASCAR, and 190 minus 111 is 79 cars that were neither. You have to know that in order to be successful with Part C, because in Part C we're asking of the model cars that were neither NASCAR nor vintage, 1/8 will be discontinued, and we want to know how many will be discontinued. So 1/8 of 79 is 79 divided by 8, which is 9.875, or 10 cars. The speed of a pitch is 78.4 miles per hour. The fastball is 10% faster than his regular pitch, and his fastball is 5% faster than his changeup. We want to know how fast is the pitcher's fastball. So we'll take the speed of a normal pitch, which is 78.4 miles per hour, and we'll multiply that by 110% because it's going to travel 100% of the normal speed and 10% more for being the fastball. When you multiply these numbers, you come up with 86.24 miles per hour. We then want to know how fast is the changeup, and the changeup is 95% slower than the fastball. It's 95% of the fastball because its fastball is 5% faster than the changeup. So we're taking that 86.24 and we're multiplying it by 95% because the fastball is 5% faster than the changeup. And when you multiply those numbers, you come up with 81.928, which means that the changeup is 81.93 miles per hour. In this problem, Brent's going to buy a scooter that is normally $159.99. This scooter is on sale for 25% off. So if we're taking 25% off of the price, then he is going to pay 75% of that price. So we're taking $159.99 and multiplying it by 75%, which is 0.75. The number that you come up with is $119.9925. So that is $119.99. But Brent is an employee and gets to take an additional 10% off. So he now is going to pay only 90% of that price. So if you take $119.99 and multiply it by 90%, you're going to come up with $107.991. And that means that he is paying $107.99. So if we round that according to our options, then he is paying $108. But now we want to know how much to the nearest dollar would Brent save off of the normal price. So if the normal price is $159.99 and Brent's price is $107.99, then he is saving $52. You can look at this with the exact amount or the rounded amounts because it does say to the nearest dollar. So $159.99 is $160, and $107.99 is $108. And the difference of $160 and $108 is $52. This is one of those typos where there was not an answer choice, so you would have to recognize that the difference was $52. Elsa is trying to run 25 miles this week. She is running 3 1/4 miles each morning, Monday through Friday, and we want to know how many miles she has to cover over the weekend in order to reach that 25-mile goal. So if she is traveling 3 1/4 miles for Monday through Friday, that's 5 days. And that translates to 13/4 times 5. That is 65/4. And 65/4 is 16 1/4. So over the week, Monday through Friday, she has run 16 1/4 miles. She wants to complete 25 miles. So you're taking 25 and subtracting 16 1/4, which is 16 2500ths, to figure out how many miles she needs to run over the weekend. And the difference of those two numbers is 8.75. So she needs to run at least 8.75 miles over the weekend in order to meet her goal. And then she could also better her goal, and that would be 12 miles or 9 miles. But if she only ran 5, 7, or 8.5, she would not have met her goal at all. So the correct answer needs to be D, E, and F. Ron painted 5/8 of a wall using 1/4 of a can of paint. We want to know which statements are true, and we need to mark all that apply. This is dealing with proportional relationships, where we're setting up a proportion and seeing if the sides are equal to each other. Again, this can be checked by division or multiplication, but in most cases, multiplication is the easiest. So 5/8 of a wall and 1/4 of a can of paint came directly from the problem, and you're setting that equivalent to each of the statements in the answer choices. So for A, 5/8 of a wall with 1/4 of a can compared to 1 wall and half a can, you would cross multiply to see if the two sides are equal. So 5/8 times 1/2 would give us 5/16. And we need to see if that is equal to 1/4 times 1, which is 1/4. Both of these fractions are simplified and they are not equal to each other. So no, this is not proportional. For B, 5/8 times 2 is 10/8, which is 1 and 2/8, which is 1 and 1/4. And we're trying to see if that is equal to 1/4 times 3, which is 3/4. And these two numbers are not equal to each other, so again, no, this is not proportional. When checking C, we're looking at 5/8 of a wall with 1/4 of a can, if that is equivalent to 2.5 walls with 1 can. So 5/8 times 1 is 5/8, and 1/4 times 2.5, we're looking at 1/4 times 5/2, and that gives us 5/8. And 5/8 is equal to 5/8, so yes, this is proportional. So C is our answer, but because this is a mark all that apply, we cannot stop here. We must check D. And 1/4 times 10, that gives us 10/4. And 5/8 times 4, that gives us 20/8. If you look at these fractions, they can be reduced. And 10/4, both of those are divisible by 2, leaving us with 5/2. And 20 and 8 are both divisible by 4, leaving us with 5/2. And because 5/2 is equal to 5/2, yes, this is proportional as well. So C and D are both correct answers.